I have this many people, 100 people, and I'm supposed to get 7,000 gallons of the plant, and I'm getting 100,000 gallons of the plant. Where do you tell them to start?
There's typical bad players. Like I said, when you do this enough, you'll know that golf courses, as an example, they do not want pools of water on their golf course. So they'll drain that water off.
Yeah. If in your city there's a rain gauge within a mile of where you're doing the study, that's going to be close enough to correlate. Maybe it's not rain gauge, it's just a seasonality thing. So essentially that dry weather data is so important because you'll see a sustained peak.
Yeah. The other thing that we use is that, which is we're really kind of specialists in the area, is using what's called an AMI network, Advanced Meter Infrastructure.
All right, thanks for coming on. I've got Mark here with Utility Systems Science and Software, otherwise known as USQ.
Correct. Yeah.
Cool. All right, so we're here today to talk about I&I, tracking it, some of the common problems. I wanted to start with how do you think of I&I, just as an overview, so people kind of understand what it is?
Well, I&I is, inflow and infiltration. So the infiltration is basically groundwater, coming into the collection system. And that typically will happen because of, maybe a pipe is broke, or there's a fitting which is not, or there's cracks, or you have maybe a high water level. And the water can be coming in through
the water table.
And then it's coming in through the actual manhole. So you'll open up the manhole and literally water is coming in from the sides. So, and then inflow, which is, water, which is, from the rain. And what we'll find is, people tie in their gutter systems, to the collection system, or they have, surprisingly, manholes with, they look like Swiss cheese, so water's coming in through that way, or just, poor fitting.
Yeah. Or a lid. So one I've seen recently is a lid of a manhole actually is in the center line at grade in a ditch. So it's coming through that.
You see this all the time, where there is an outfall from a storm drain, and it's sitting, and then right below that is, a sewer manhole. And so it's below grade, and there's only one place for this water to go, and that's into your collection system. So, and that actually is part of, it's not just about flow monitoring. It's also about, being a little bit practical as to what what are you doing? So we'll look for just that issue, or those groups of issues. And there's a variety of ways to find it. Sometimes through smoke testing is very popular, but sometimes you literally can just go through the neighborhood and look, and you'll find these problems.
Go through meaning like you'll see if you just watch where water drains, for example, surface drainage, or a downspout tied into a clean out.
Absolutely, all of these. You do this enough. We do this absolutely every single day. 7 days a week, 24. And we do a lot of our flow monitoring at night, just because we have control of this, the streets. But, as you're doing a survey, you can see the outfall, let's say, of a storm drain. You go, well, you don't have a riser on this manhole. And I'm not going to name cities, that we see it, but we've seen it recently, as in this month, exactly that problem. So it's, and that all just goes into a report. We take photos of it and try to identify not only the problem, but what practical solutions are available, to reduce this issue.
So you mentioned flow monitoring as a way to locate it. You mentioned smoke testing. You can camera lines and stuff, but you also mentioned flow monitoring as a way of not just maybe locating, but also quantifying it. Kind of how do you it? Yeah. So approach, kind of starting. All I know right now is I have this many people, 100 people, and I'm supposed to get, 7,000 gallons of the plant, and I'm getting 100,000 gallons of the plant. Where do you tell them to start?
Well, it starts with the sewer map. Most cities have a sewer map. And what you also find is that the cities, they know approximately where something's happening. They're really very knowledgeable. We're coming from the outside. Maybe we're in Texas or Boston or Los Angeles, and we're going to say Idaho. They know their town really well. They know where where they can see issues. But we also will go on, we'll superimpose the sewer map on top of, Google Earth. We superimpose that data, and there's typical bad players. Like I said, when you do this enough, you'll know that golf courses, as an example, they do not want pools of water on their golf course, so they'll drain that water off. Well, it doesn't mean you drain it off into the collection system. So we know that school systems, they don't like water on the.
That's actually one that happens a lot. I'm shocked that you know that, because
shockingly happens a lot, and so we take the sewer map, and then they have some ideas of where it could be. And then what we do is, because we do this absolutely every single day, we'll know, I would suggest we look at this right here. And we were in, say, Chicago. And who was the bad player? It was some elementary schools, where they do not want rainwater on their property. And they tied everything into the collection system. And the collection system in Chicago, which is a very good system, is not designed for stormwater.
They're just designed for a diurnal flow pattern. They're designing for storm patterns.
Exactly. So a lot of stuff we do is, there's no real magic in doing this. It's just, you do it enough, and then there's some trends.
So there's some trends in terms of who common offenders are, and then also that the boots on the ground have good contextual and anecdotal evidence to help kind of start where to look.
The technicians for cities, they're super knowledgeable about their system. They really know. We don't think it's over here. We think it's over here. And they're just incredibly, they really know it. And so we work with them. But then we back it up with data. So we put a flow meter in where we think we're having a problem. And so we need, two different types of data. We need dry data, and we need wet data. We need wet data being that rain data. We also try to quantify that rain data. We'll have rain gauges, and we try to use, there's a lot of free data available through NOAA. So we don't necessarily need to put rain gauges in unless it's not being covered by some free data.
So if in your city there's a rain gauge within a mile of where you're doing the study, that's going to be close enough to correlate?
Perhaps. It's possible. It wouldn't hold in cities where there is, it could be hilly. What creates a microclimate could be just vegetation. It could be a mountain, a hill in the way, or buildings. You go into a city, a microclimate could be caused by, some skyscrapers. And they have. You've been in cities where, let's say we'll go back to Chicago, and they call it the Windy City for a reason. And you're really surprised at how much wind is there. Well, for a rain gauge, then we may need to put some additional rain gauges in. And once again, that comes down to looking at where they're monitoring, how often are they being serviced, are they actually working perfectly, have they been calibrated, all those issues. So we look at that.
In Colorado, there's a lot of snow melt runoff that is contributing to our systems, and so maybe it's not rain gauge, it's just a seasonality thing. So essentially that dry weather data is so important because you'll see a sustained peak that'll happen.
Well, in Colorado, so we do a lot of work in Colorado today, and so we're also looking at temperature. What we find interesting is you'll have a snowpack of, say, 6 feet, 9 feet, 12 feet. You really have, it changes year to year. And what we found is that it could be like sustained 30 degrees, 25 degrees. And then the following day, it goes like to 70 or 80 degrees, you know, and so we'll be able to see it. So we're also monitoring the temperature, along with that. Or there might be, maybe I have this snowpack and then it starts raining and then it gets compounded into actually almost a river coming down that,
The rain's warmer than the snow. It's melting it, and you've got the rain itself to do it. So it's like double. Exactly. You'll see a 1-inch event, but it's like a 4-inch event, kind of like impact.
So there you can see that we really need to have the dry weather data. And then for the wet weather data and or any kind of environmental conditions which can impact, you know, water coming in for inflow. We're looking for inflow. With the dry weather, once we have this data, then the other thing that we use is that, and which is we're really kind of specialists in the area, is using what's called an AMI network, Advanced Meter Infrastructure. This could be ITRON. A lot of cities and what you'll find in Colorado, they have AMI networks. There's a variety of them. And, you know, you have ITRON, you have Census, you have Aclara, or they might have LoRaWAN, and often a lot of them now are on cellular, where the water meters are communicating through these AMI networks. So we want that AMI data. We superimpose the AMI data, which is water meter data, with our flow monitoring, and we'll be able, there should be I won't say a one-to-one relationship depending on irrigation, but we'll be able to trend this data, the water consumption, to the dry weather data. And if it's not, then we know where else it's coming from.
So meaning if I've got 10 homes and I registered over that day 1,000 gallons, that I should see a relationship to, like, maybe it's only 900 gallons, but your point is it's not 1-to-1, but maybe I should see around 900. It should be 2,000.
It's not going to be 2,000. Correct. Often it's going to be, we should be seeing less water, not more. We shouldn't be we're not generating water. We're consuming water.
Right.
So, but this is super valuable data. The other thing we do is let's say you do this all the time. This also, sometimes you have to go old school. Rather than just doing flow monitoring, we also just start observing the color of the water will change. When you have a snow melt, and it should not, that snow melt water should not be in the collection system. If if it looks perfectly clear, good, it looks like drinking water, you don't need to do flow monitoring for that. So you just need to start going upstream and find out who's the culprit.
Where does the color quite literally switch from clear to dark?
Yeah, there you go.
Between those two.
There you go. You got
That's a really nice, simple way. You don't want to overcomplicate. Y'all don't want to come in here and overcomplicate it either.
No, and this is why, we're here at WEFTEC 2024. A lot of engineering companies use our company for exactly this problem. You name the company that's in here, that's especially the consulting companies. Yes, they're doing the project. Yes, they're doing the analysis, but they'll use our company to provide all the instrumentation, the people, and everything it takes, to perform this function. And we work together with the city, and we'll identify very quickly where it's happening. This does not take years; it takes weeks. Weeks.
Because that's been one of my frustrations, is kind of talking to other providers, and one of my experiences was it was going to take 2 years to get to a decision-making point on where it was and stuff. And just to give you some context, this community was looking at, should I fix the problem or should I upgrade my plant to do more capacity? And you've probably seen it. Sometimes it's just one section of a pipe. We're not talking about thousands of feet of pipe that have to be fixed.
I can't tell you how often we see this. We see it all the time where they are planning on upgrading their water treatment plant, and they may need to upgrade their water treatment plant for other reasons. But what you don't want to be doing is processing clean water, rainwater, groundwater, and they may very likely have to do significant repairs on their collection system, and we'll be able to identify precisely where it's occurring. but we go after the low-hanging fruit. Start with the low-hanging fruits. Is there anything practical we can do to solve this problem rather than doing a relining or you will find that there, the practical solutions you'll find, we were in Oregon and they were actually planning on upgrading their treatment plant, but we found the culprit, and it was a significant culprit, and it was and the fix was really inexpensive.
Under $100,000 or?
Oh yeah, way
yeah,
like $25,000, and it was nothing. It was absolutely nothing. And the part that surprised us was, why didn't the city see this before? They were looking right at it. It's not so similar. Do you have children? I don't know if you have children, but a child observes something and you're going, oh, you know what? You're right. Because they're seeing it with a fresh set of eyes.
Oh,
and so that's exactly what happened when we were in Oregon. And I'm not going to name the city, but I apologize.
No, it makes sense. Can you kind of talk to me? I've seen a bunch of different ways of monitoring a manhole itself. Can you talk to some of the techniques, the level of accuracy that you guys deploy or prefer in certain methods?
Yeah, so accuracy is always the issue. And there's really only a few different technologies out there. And so a big part of accuracy is starting with whatever instrument you're using, the calibration process, and validating whatever the city tells you it's a starting point, but we do not rely on that data, almost never. We've changed how once again, we're trying to automate and trying to reduce the costs. And so one of the things that we do today is we at every manhole that we think that we're going to be monitoring at, we send down a 3D camera, or maybe you might put in a LiDAR camera, and we send that down. And we take complete measurements of the whole system. And then what we'll find is what the city thought was their as-built conditions will be substantially different. And substantial can be, they thought that they had a 12-inch channel when they actually had a 10-inch channel. And that's, they may have modeling based on this. They may have all kinds of engineering analysis based on that 12-inch channel, when the reality is they have something completely different. The other advantage of doing a manhole inspection is it identifies cracks and just, do they need any kind of rehabilitation? We don't provide that service. We give this data, to the city. So the calibration process, taking all of your measurements, I don't care what the instrument is. I don't care who the manufacturer is. If your calibration is off, the data is off, and it can be, if you're just a half an inch off, it changes absolutely everything. And so your site sheets, we start there. We are a believer in there's two main types of flow monitoring, and one of the things that we do is you're either going to go a non-contact flow meter or an inflow type sensor. Both are extremely accurate. The technology of the instrumentation that's used today is, it's just absolutely excellent. We are a believer, though, although we sell and we also service with just using a radar level sensor and then doing a calculation, say using Manny's equations, that gives you an idea of what's going on. But in our world of doing I&I, we really want to know the velocity of the flow. So we use a Doppler radar for...
It could be flat in that channel. It could have a huge pitch, and that's kind of the point to your site sheet.
Right.
And so it's just going to be different.
It's very different. And so as part of our calibration process, we also use a secondary calibration sensor. So we're really we spend a lot of time just on calibration, making sure that that instrument is reading what we really believe it should be reading. So calibration is the big one. So, and then of course, then you have, we're not believers in putting sensors in for years to identify where the problems are. We want to, I'm not we think it takes weeks, maybe it takes a couple months. Really what it happens, we were talking about the dry weather data, wet weather data, and then your AMI data. The AMI data, by the way, really pinpoints where the problem is. It's on every single home. It's a water meter on every home. So the granularity of that information is it's a game changer, of how to identify.
How to quickly move. Kind of when you're talking about condensing that time frame down, which is what they're really interested in. And so you're able to move a lot faster because you have a little bit better data. So
if you're only using flow monitoring, it's going to take you, and it's not just you're putting a flow meter in, you got to move that flow meter. Well, what if I have this granular data from a home or from a business complex or from a factory? All that data is available, and and it's free. It's free data. So it all comes into, like I say, we work with the other engineering houses, here at WEFTEC, and we work together and put all of that into a model, and off you go. And we're going to be able to identify, what's going on, quickly.
Okay, cool. Thank you so much for sharing your tips and tricks.
My pleasure.